Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I am Michael, founder of PG Mustard. This is my co-host Nikolai, founder of Postgres AI. Hello, Nikolai. What are we talking about this week?
Hi, Michael. We're out of disk space. What to do?
Panic.
This is what Postgres does, right?
Yeah, in some cases, right?
Yeah, well, I saw it a lot. Recently saw again, actually. And yeah, it's not fun. Why panic? Don't panic, right?
Keep calm and carry on, right?
Yeah, it's Postgres. You should, yeah. Just use Postgres, so as we discussed before this call, before recording, let's just talk about possible reasons, mitigation, and avoidance, right?
Yeah.
Prevention is better.
Avoidance.
Denial.
It's like the stages of grief. Yeah.
It's not my problem, actually. Yeah, I'm a DBA. It's a SRE problem, right? They should just give us more space. To start about problems, I mentioned it before the call, but let's repeat. The only true reason of this is an insufficient disk space allocation. It's always so. And it's a joke, but we will be returning to this joke, I'm quite sure. Because sometimes you do need more space, that's it. Of course, I would deprioritize this path and consider everything else. But sometimes we end up with this reason and mitigation action, like just add disk space. But let's consider this as a last like resort, right?
Mm-hmm. Well, yeah, I like your structure. So like causes, then recovery, and then mitigation or prevention.
Mitigation is recovery.
So okay, great. Prevention being the last one. So causes, what are the like most common reasons you see this happening to people in the wild?
Good question. There are many reasons. I don't have statistics.
I can tell you the one I see most blog posts about, because I don't see this that often, but the one that comes up time and time again in blog posts is an open replication slot.
It's like it's too narrow. Let's just say a lot of WAL written. And,
yes.
Yeah, and it remains, a lot of WAL files remain in PGWAL directory. Or pgxlog if we talk about ancient versions of Postgres.
Yes, but that's the root cause of why it's the most common one I've seen.
I think it's super popular reason, but I would structure this like if we need to provide comprehensive list of reasons, I would put it to the second place, and for the first place, I would put and I, not only like because of slots. Slots is just one subsection here. Whole section is just PGWAL directory takes a lot of disk space. This is the big class of reasons, right? But the very first class of reasons, I would say anything related to data directory itself, like a lot of disk space consumed by tables and indexes, right? It's also like a whole class, so we have like specific reasons inside it.
Yeah, so we actually have more data than the size of
than we expected. We try to delete, but the space is not freed, and so on. So
lots of bloat, for example, that we talked
data
about.
related, WAL related, and the third class probably or category is probably anything else, right? Because anything else is tricky and interesting. We will talk about it soon, right? So how about this?
Yeah, just to give people an idea of the anything else, like you including logs in that, like things that can grow quickly that aren't data, like main data directory stuff or WAL.
Base subdirectory is where data is stored. So if you think about PG data directory structure, we can think about base, so the tables and indexes, right? Materialized views as well. And then PGWAL subdirectory, and it is huge, for example. And everything else is interesting as well. Maybe also outside of PG data, but let's not reveal secrets, right? Before it's time. So what about tables and indexes? What do you think? Like possible specific reasons? Like I deleted 90% of my table but it didn't help. Disk consumption is still 99%. What to do? Time to panic, right? So, like, obviously, delete doesn't delete data, right? It just marks it deleted, but it's a two-stage process.
Well, and this is a tricky one, because a lot of the times we've discussed how to deal with issues like this, we actually require quite a lot of disk space in order to repack or to actually mitigate that problem. The easiest way, the way that to do that in an online fashion, requires double the size of the relation or double the table size normally. So it is a tricky one in this case. Yeah,
exactly. It's just a few days ago, I was discussing this exactly problem with one of our customers, and they mentioned that like they have a huge table which consists of like 90% of their database, and to fight with bloat, they know there is bloat, and to fight with bloat, especially in heap, it's obviously you need to use PG repack, and to use it, you need the same size. Like you need to have temporarily, you need to have two large tables of same size, because it rebuilds the whole table in background and then switches to it. So yeah, this is a problem, and if you don't have enough disk space, oops. But yeah, so this is I would say this is edge case. Normally there is no single large table which is like 90% of whole database, right? So normally it's not a big problem, and if we keep free disk space 30-40%, which should be so, like at least 25% maybe, we have this space. And we know it's just temporary. We like just when we're repacking the heap, the table, right? Not a problem usually. But if you're in this situation, well, not good. Maybe you should do something else. There are alternatives to PG repack. I think PG squeeze alternative from Cybertech also has this issue. It requires additional disk space because it rebuilds the table. But older solutions, like in this particular edge case, I would think I would return to solutions which exist for quite some time, several implementation of not let's rebuild table, but another idea. It's called PG compact table. Again, there are 3 probably attempts from different persons to implement this idea, and all of them I think are in Perl. But idea is, let's issue some updates which don't change data. When you issue update, even saying update blah blah set ID equals ID where ID equals some number, a new tuple is created always, right? So this tool is issuing these updates in a smart way. It checks which tuples are in the end of table, and it knows there is bloat, so there is empty space in first pages, for example. So if we update tuples which sit at the end of table, they will move to the beginning of the table. And once there are no tuples left in the final page, final block, it will be truncated. By default, is what vacuum does, unless it's turned off. And then we do the same with next from the next page, and so on and so on. Like basically, this is similar to like I remember in Windows, like defragmentation, right? So it's moving data to different places.
Remember that defrag screen on Windows?
Yeah.
People love that.
Visualize it. Yeah. Like maybe like with red and blue, right? So yeah, and this is much slower process than using PG repack for table, but
also in our case, if we are actually out, if we notice we've got 99% disk full, maybe this kind of thing helps. But if we're actually out of disk space, this isn't an option.
Oh, yeah. This I'm talking about mitigation here, maybe too early, but of course, if we already achieved 100%, we like cannot move. It's not like what I would do. But you just raised a very good point about extra disk space needed, and I just remember there are alternative solutions, and I think they don't require any extensions, so they could be used in anywhere.
True.
Like RDS, Cloud SQL, anything. Like it's just simple updates, super slow, but not requiring extra resources, which is great. Also, probably you will need to make sure the tool is working well with current version of Postgres, because they are quite old. And again, there are 3 of them. I think Depeche also tried to implement one of them. Like,
that makes sense that it's in Perl then. Yeah.
This is a small zoo of ancient tools. And I like the idea, actually. So, yeah, but it's not an emergency tool. It's like right before emergency tool.
yeah.
Trying to avoid it. So, yeah, this, right? But as for indexes, probably, yes, when we rebuild index concurrently, like Postgres builds another index. But I think this should not be super noticeable, because no index can, like, yes, it requires like extra disk space, but we should have it if we do it right. So anyway, if we delete, we should think about, okay, that tuples and bloat. Keep it in mind. Try to avoid massive deletes, or design them properly with MVCC and vacuum behavior in mind. Right?
We did a whole episode on that, I think.
Right, exactly. Yeah. So, yeah, I saw crazy cases when some tables and indexes were bloated like 99%.
Yeah. And you saw these cause out of disk issues?
Well, they contributed a lot, and
sure.
If we keep it as is, we will soon be out of disk space. Right? So it's definitely worth keeping an eye on the situation in this area, bloat and vacuum behavior. And yeah, if you don't do it and do it very like infrequently, then you once like in 5 years you take care of it, and then you realize out of 10 terabytes of disk space you had, now it's below 1 terabyte. And what do you do with other 9 terabytes? You keep paying the cloud provider, right? Because it's easy to add disk space, but it's not easy to reduce disk space, because they don't have such function. And it's possible only if you create a new standby cluster with smaller disk, and then just switch over, right?
Yeah. But so, it's quite funny seeing that message. This is a one-way ticket.
One-way ticket, yeah.
So I think those make sense, right? Normal data exceeding the size of the disk, whether that's actual data or whether that's bloat, makes perfect sense. Do you want to talk any more about?
Of course. Actually, I still believe, since VLDB in Los Angeles, I think in 2018, I still believe in keynote there. I like this keynote about like data deletion is huge, like big problem we engineers need to solve and find better solutions. So sometimes it's not about bloat. It's about like a lot of garbage, duplicated data also. And I saw many times when we start paying attention to bloat and pushing customers to fight with it, suddenly they say, you know what, I had it like maybe a month ago. You know what, we don't need this table. Let's just not spend time and just drop it table, or truncate it. We don't need the data. And it's like, wow, some terabytes are free. So
yeah. So I see this with like analytics data, for example, people tracking everything. Like they don't know, they never look at their analytics, they never look at who's using which feature, but they track everything because we might need it someday. Or, like there's all these data use cases. And even the solution to this, like in terms of, well, I've heard the phrase retention policy. I know it's not quite the same topic, but talking about how long we should retain data for, even that we don't even mention deletion. It's not deletion policy, it's retention policy, which is quite funny.
Also, maybe one of the last things in this section I would mention is it's becoming more popular, instead of deleting all data, to have some better approach, tiers of data storage. And I know there is from Tembo, there is extension called PG tier. First of all, Timescale has this, right? But in cloud only, I think it's not open source feature. If I'm not wrong. Well, and so idea is let's consider some data archived, and it still like looks like it's present in Postgres, but it's not stored on expensive disk, which has also capacity limits. We offload it to object storage like S3 on AWS. And this is a great idea actually, but I think some like latency issues will appear, and also maybe some errors sometimes, inconsistencies or so. Like it's interesting, but it's a great idea. And as I said, Tembo has a PG tier extension, which I hope to test someday when my team has opportunity and time for it. It's super interesting to check how it works. And I think it's a great idea. Like if you have some huge tables, maybe already partitioned, you can go either with sharding, or if some historical data is not needed all the time, you can just offload it to object storage, which is like virtually infinite. And then, users experience some worse latency when reading this old data. Imagine e-commerce, for example.
Just to quickly, I feel like this is an old-fashioned solution to this was table spaces.
Yeah, but table spaces in cloud reality became not popular at all. Last time I used table spaces in serious project was more than 10 years ago, I think.
Yeah, but that's what I mean. We had this before. It's just it had a different name, like it.
Maybe yeah. Table spaces, you can have cheaper disk attached to your machine, but I still don't like this particular approach, because I like as offloading to object storage more. Because imagine you have primary and multiple standby nodes. If you use table spaces and cheaper disks, you are forced to use the same structure of disks on each node, and it becomes still expensive and slower, for example, right? While object storage, it's worse in terms of uptime compared to EBS volumes on AWS, for example, but it's much better in terms of reliability, or vice versa. I always like
durability, or I don't know.
If you check, availability and durability. If you check SLAs, S3 is I forget. So if you check characteristics, you think, this is what I actually would like to have for archived data. Maybe latency will be slower, worse, right? But if you think about e-commerce and order history, for example, if you large like e-commerce website, if you have ability to offload all the activities, and like users touch them very rarely, right? But it's still good to have the ability to see the old order history, right? But it's not needed often, so we can keep it outside of Postgres and evict from caches and so on. And don't pay for our like main cluster. We just pay for S3, and there we also can have tiering, right? Usually,
true.
Because and even automated. Usually, providers have these features. Like if it's older than like 1 month, it goes to some colder and cheaper space. So I think this direction will receive some more popularity and will be better developed and so on. Tiering for storage.
Once again, we've been sucked into kind of like prevention.
I think it's hard to talk about reasons, and then I like this is a big flaw of the structure I proposed.
Well, no, I like it still, but it feels like we haven't really touched on
the most popular. Let's talk about WAL, right? We have some. So PG WAL is huge. We identified it, which is actually already some good skill. Not everyone can do that, but if you manage to identify that your PG WAL data is huge, there are a few certain reasons, and there is a good article from Cybertech about this. Why Postgres doesn't delete WAL files? It's already time to delete
the various reasons.
This is exactly when we need to apply this article as like the list of possible reasons and just exclude one of them until we find our case, our real reason. So one of them you mentioned, some replication slot, logical or physical, not progressing and accumulating a lot of changes. It's not like accumulating. It's not like slot Postgres doesn't write to slots. It writes to pgvol, a lot of vols, right? But slot has position, and if it's inactive or position is like frozen, consumers don't consume and don't shift this position. It means Postgres must keep those vols in pgvol directory until it finishes. And since recently, a few years ago, one of, I think Postgres maybe 13 or 14, received a setting to limit this, to have threshold when we give up and say, let's better to kill our slot, to destroy our slot, and but let's stop this situation, and vols should be deleted already. And I remember this big fear in good engineer I worked with. He was not Postgres, he was more SRE, but with a lot of Postgres experience. And when it was long ago, when initially replication slots for physical replication were introduced, we had basically a small fight. Like I said, let's use it, a great feature. He said, no, I'm not going to use it. He said, like, this is super dangerous. And he understood that the danger is if some replica is somehow is stuck, slot is not progressing, the primary is out of disk space, and this is the last thing he wanted. After lost backups, of course, right? So, but over time, we started using slots, but then this setting, I think it's a great setting. You can understand your disk layout and how much free disk space you can afford. Like, if you approach like 90%, it's time to kill slots. So you can do some math and understand that maximum number of gigabytes you can allow for a leg is this. Of course, over time, database grows, and still this like it still can be a problem, right? Because if data grows, tables and indexes grow, and probably your setting will not save you from emergency, right? Maybe. So, but this is definitely one of the reasons. What else? What reasons? Because of failing archive command, right? Because for Postgres, it's important if archive command is configured. For Postgres, it's important to archive. And if it's failing, any reason can be. Postgres cannot archive, so if it cannot archive, it cannot remove these vols. And that's a problem. So you should monitor archiving command lag separately. And if it's growing, it's very bad for backups already. But it's also bad because it can hit you in terms of disk space. So yeah, these processes, replication and archiving of vols, are two processes that if something is wrong with them, Postgres cannot remove vols, right? Another reason, actually,
and this, by the way, this can grow quickly. I think people don't always realize how quickly this can grow, even with small database.
Yeah, it can be small but very active database, and you can have terabytes of vol generated per day. It's actually good to know how much you generate per day or per hour, per second. So
I think even with like a low activity, as long as something's happening every time there's a checkpoint, I've seen people with toy databases like like free tier RDS be surprised that it's generating like a couple of gigabytes a day, like 64 megabytes per 5 minutes or so. Adds up quite quickly with small.
Funny reason I also can mention, you have not a huge database, but also quite active, and you think, it's time for checkpoint tuning. We had an episode about it. Checkpoint tuning. Let's raise max vol size and checkpoint timeout. You raise it, but you didn't do proper math in terms of how much disk space you have, and end up having too big pgvol. Because distance between checkpoints increases, and Postgres needs to keep more vols. So, and this can be just a mistake of configuration.
Yeah.
So and after this, I think we can move on and let's talk about other reasons. Other reasons.
Yeah. What else do you see?
I would put on the first place in this category log directory.
Yeah.
Especially if it's inside PG data inside this main Postgres directory. Especially if log directory where Postgres writes logs, if it's in the same drive as data directory. for example, inside PG data, or just next to it, but on the same drive. If logs are like suddenly, like we have some performance degradation and log mean duration statement is configured or auto-explain, or for example, we decided, oh, we need more audit and PG audit is a great tool, right? Let's bring it. It starts writing a lot to logs. And if you didn't separate your data from logs, you should separate. I'm not talking about PGWall. I'm not a big fan of having separate disk for PGWall, actually. It's it was a thing in the past, but recently I don't see benefits from doing this often. Benchmarks don't prove it and so on. So it depends, of course. It depends if it's your own data center, maybe it's worth doing this. But if you don't offload logs, regular logs, and keep it on the same disk, then you bring PG audit, they suddenly start writing gigabytes per, I don't know, what hour, and maybe some problem with rotation of logs.
Yeah.
Like retention or rotation. So they are not deleted properly, for example. And then this can hit you badly and you have panic, actually, for your database and selects are not working. But if you offload it to different disk, and at least with logging collector enabled, I know that database actually will be working fully. Then that's great. I actually recently, maybe a few months ago, I had this experience. I expected, I got used to it. Postgres is fully down if we are out of disk space, and I expected the same behavior when our log drive is full. If we offload it, if it's full, I expect big problems. Postgres didn't notice almost. So okay, we cannot log, but we keep working. That's great, actually. So this is super big benefit of having different drive or regular Postgres logs. And even if it's slow, it can affect performance, right? But if it's 100% full, not that bad. So
yeah, we've talked several times about excessive logging having an impact on performance.
Observer effect.
Yeah, and I've definitely done benchmarks. This is the age-old log min duration statement 0. Like why we recommend I recommend never setting it to 0, because this, like, you can generate gigabytes in like a 30-minute benchmark, like with PG Bench or something. So it surprised me how much it can grow.
Yeah, it's actually a good idea maybe to just maybe to ask our bot to benchmark with regular PG Bench and then to have sampling for logging of queries in one way or another, and just to see how observer effect grows and kills your performance. Yeah. Only people with small databases can recommend log min duration statement 0.
Or quiet databases, yeah.
Quiet, yeah. Not active.
Yeah. Not active.
Small databases and small workloads. That's it.
So, yeah. Yeah. Or I guess super low, like turn it to that, but only very, very briefly, like a minute or two or something.
Yeah. So for serious workloads, you cannot do that. I already shared my experience putting big critical databases productions down, and don't repeat my mistakes.
As well as logging, like what else did you have in this category of things that you've seen?
Oh, that's a good question. Well, let's not maybe spend too much time discussing some unknowns or external things, like we have, I don't know, something else installed on the same machine and using the same disks, and suddenly we are out of disk space. Also, it can happen sometimes. Or maybe, for example, you do some troubleshooting, you have self-managed Postgres, you can SSH to the box, you started sampling every second some good logs, but do it to, for example, to home directory, and then it's full or something like this. So you always need to be careful with that. But interesting case when, for example, you try to upgrade, you have Patroni, I don't remember exact details, but in some cases, Patroni decides to retry provisioning of a standby node, for example, and it fetches PG data in the way you configured with PG base backup or from archives, but it renames the old directory to make it like backup, not like local backup, right? It just renames it, and you end up having two directories suddenly, right? data directories full-fledged. Like, wow, it can quickly be a problem in terms of disk space. What else?
So does that mean like if you had, let's say your data directory was about 40% of your disk size, so you thought you had loads of headroom, suddenly you're at 80% plus whatever else is on there.
Yeah.
Okay. Wow.
Maybe large temporary files, but it's quite exotic. I like they can be huge, right? But it's exotic.
I saw some Stack Overflow posts mention that, people that were out of disk got the error, but when they checked, they did have free disk space. And one of the suggested answers mentioned check for temp file. Like your queries could be doing a lot of temp file stuff, but yeah, I've never seen that myself. What about backups is an interesting one. Like backups, because some people recommend keeping some, obviously keeping all your backups on your on the same disk as your database is suboptimal for recovery purposes, but keeping some on it makes sense, especially for huge databases, right?
Like I don't think so. Recovery. I would not recommend doing this.
But what about for recovery? Like no network. I'm just thinking about like
regular backups should be separate, of course.
Mm-hmm.
But if you do some operations manually, for example, you decided to back up some tables and just, like dump them to some compressed form and keep on the same drive, well, it might happen, but it's like there are many mistakes you can do manually.
Right? Fine.
Or you just create table as select, for example. You basically just cloned table and then forgot it. Well, many such mistakes can be done. Right? I think there are many exotic situations we don't discuss here, and I'm curious if our listeners had some interesting situation we didn't discuss yet. It will be interesting. Like I think many exotic things can happen. Let's talk about what to do in emergency, right?
Yeah.
First thing, understand the reasons, right? Or maybe no. This is actually
I don't think so. Yeah. I mean, bear in mind, if we're actually in an emergency, our database is no longer not only not accepting updates and writes and things, but it's also in a lot of cases not accepting selects, which
is ridiculous, right? Yeah, you shared with me before our call. You shared Ivan doc, which says if managed Postgres service has automation, if it understands that we are approaching a full disk space, it converts our database to read-only state, right? Just setting parameter, which actually any client can override actually, right? So it's a weak protection. Default transaction read-only turned on, right? This parameter, default transaction read-only. I like the idea actually because it's weak protection, but it's quite reliable if you don't have this set to off all the time in your code. Usually, there are low chances you have it in your code, so it means that it will protect you. And then you have alerts. You need to have proper monitoring and so on. But this is like prevention measure, maybe.
Yeah. Again.
It's again prevention. Yeah. But if you're in emergency, this is like I think we should write some good how-to. In general, how-to for any case.
I did check your how-tos, and I was surprised not to find one for this actually.
Yeah, but it's a miss.
I think also one thing worth mentioning. Nobody's going to be listening to a podcast and be like half an hour in or whatever, and be like, because they're panicking.
It's Googleable.
Yeah, but
and AI-able also.
One thing to remember that does seem to catch people out is, I mean, hopefully everybody listening here this won't happen to, but they know that WAL stands for write ahead logging, assume that it's logs and therefore can delete it. And then because it's like a large amount of what they think are logs, they delete those to try and recover. And I think that the main advice from me in terms of recovery, from every guide you'll read on this, is don't do that.
Yeah, I would say the classic approach is understand reasons and fix them. Mitigate, right? But you might have pressure of time. In this case, it's good if you can quickly identify something you can delete safely without big consequences. For example, regular Postgres logs. If you have a lot of logs, gigabytes, it's good to delete just one log, like one file or so. Start database if it's down, and then you do need to do full analysis and mitigate the real reason and so on. Or maybe you can delete something outside Postgres data directory, something. You can check quickly if there are different directories around which have some gigabytes of data. You can or at least megabytes, so you can quickly delete and let Postgres behave normally for quite some time. It buys you some room, right, for analysis and proper mitigation. But mitigation is inevitable. You need to understand what happened. Is it vol or data or something else? And then you need to mitigate.
Yeah, I was reading some guides on this. There's a good one on the Crunchy Data blog, and they made a really good point that we don't all think of doing when you're in that kind of panic mode. Get things back online is my primary objective in cases like that. But they recommend taking a file system level copy of everything in its current state. Like get a snapshot of the current directory as it is before you start deleting things.
Yeah, it's additional good advice.
Yeah, because it takes time and we're down.
Yeah. In cloud, actually, if you don't see what you can delete quickly, like, and in cloud it's managed, for example, you cannot go and run du, df, and so on. But in this case, probably it's easier just to add a few % of disk space quickly, to buy some room again, and then to investigate. Obvious approach, right?
I also think because of some reasons we're going to discuss in a bit, this is just so much less likely to happen in cloud environments. Like, it just feels like this is one of those features. There aren't that many.
This is their job, right?
This is one of those 2 or 3 features that they really do manage and can manage for you automatically.
Notify properly and so on, right?
Or autoscale. Yeah, you just don't hit this problem.
I don't like autoscaling in this area because it's autoscaling of budgets.
Well, but it's also not solving the root cause of the problem. Several of those problems we talked about, it's not your actual data growing. It's not your it's not your true tables and indexes. It's write-ahead logging going out of control because of an open replication or like some reason that it shouldn't be that much data. So auto-scaling those is just not solving the problem.
Exactly.
So, yeah.
Like hiding dirt under the rug, that's it.
As long as you've been told when it has scaled up, then at least you can go and investigate.
Yeah, so I think we covered quite well mitigation in general. And
what do you think about? Yeah, I think increasing makes sense. I saw some warnings not to increase in place necessarily. Like maybe look at setting up a replica and failing over, but I thought that would be slower. Like I wasn't sure myself.
I don't know. Like, I think if you can add space or delete something safe, it's good first step. Then you have big step of analysis, proper analysis, and mitigation of true reason, main reason why you approached it and not noticing. Right. Yeah. So a big part of mitigation, if you perform proper root cause analysis, I'm quite sure will be we didn't notice this and it's a problem itself. So our observability is bad.
Yeah, either monitoring or alerting is. In fact, we have to go to prevention.
Yeah, prevention, I think philosophically is quite simple. You just need the better way to prevent it is understand and keep on good level of understanding of how you spend your bytes of disks, of gigabytes. So you understand the layout, you understand vol data, real database data, is it actual data or a lot of bloat, and then you understand logs and everything else, and you understand, okay, we are good and we understand how we spend our disk bytes. And if this understanding is good, everything will be fine and you will notice problems early. But if you but it's hard to do if you have hundreds or thousands of clusters, right?
Yeah.
In this case, you do need some rules to be alerted if bloat is high, if pgvol grows without good control, if logs are not properly, also logs consume too much. You just need to have good observability, right? To have mitigation, and then you just with understanding of possible reasons, you navigate in these reasons and find mitigation. But the key of prevention is understanding, and understanding is observability, right?
Yeah. 2 other things. I think, whilst I'm kind of against auto scaling in principle, I think it's if you've got the option, going up in budget and having to like migrate later back down to a smaller size is so much better than being down, that I personally would have that on myself if I had that option. And I think also oversizing, like disk is so cheap compared to everything else we're doing, unless you really are in the like extreme,
Disk is not cheap if you have a lot of terabytes and many standby nodes, and it can be not cheap.
But most of us aren't in that case. Like most of us aren't in. So yeah, I agree that for like people with serious data,
but some people pay like millions for disk space. It's like it can be a headache. That's why I mentioned PG tier as a quite a very good, but potentially good thing, and tiering is good. And like some design, understanding the like structure of your disk space consumption, you design some rules and offload data properly and keep everything under control. And this is good. This is good. But yeah, I think
imagine advising some startup and they had like some 10 gigabyte disk or something, and their database was only a few hundred megabytes. The cost of being on 100 gigabyte disk instead is just so tiny. Like it's just such a small. Anyway, but yeah, I take your point.
But again, I think observability can be always improved. I think so. Like especially if we know that this is PG Vault, this is data, this is logs, everything else, and we have some proper analysis and alerts for it.
I think that's the bit trips people up. I think a lot of people actually have quite decent observability, like they can see what's going on, but alerting, people aren't getting alerted early enough, or not at all is the one I see quite often. No alerts at all for, disk is at 50% sends an email, 70% raises like 90% sets off a page, like these kinds of like serious alarms.
Yeah, I know we need to go already out of time, but let's mention some small practical advice in the end. If you cannot SSH to the box, for example, it's RDS or other managed Postgres service, and Postgres is still alive, but you wonder why the disk usage goes up. At SQL level, you can check what's happening in directories using pgls dir, pgls wall dir. There is a set of administrative functions which allow you to inspect the content of directories, and this is very helpful when you troubleshoot and understand what's happening. And maybe also can be helpful in mitigation activities in observability. For example, if you have a report triggered that out of disk almost soon we will like usage exceeded 90%, then you can include some analysis automated to have a snapshot of what's happening in key directories, right? And understand what are consumers of disk space, right? Yeah. So just some advice I thought we could miss, right? Let's not miss it. That's it, I think, right?
I think so. I hope none of you ever actually have to face this, and you can all mitigate or prevent it from happening. And yeah, thanks so much, Nikolai. Catch you next week.
Thank you. Bye-bye.